Hey folks, so this is going to be a video over section 6.2. We're going to be dealing with the unit circle in radians. So looking at this first graphic here, we've got the unit circle. Remember, that means that the radius is equal to 1 unit. The center is at the origin. When we're working with simply the unit circle, not just some other x and y axes, but when we're working with the unit circle, what we find here is that my sine values are always going to be really closely connected to my y values. And in fact, on the unit circle, they are exactly the y values. Think about the fact that sine of an angle is going to be the opposite over the hypotenuse, or the y value over the r value. When your r value is equal to 1, like it is on the unit circle, then my sine value is exactly going to be the y value on my unit circle. So one thing to really pull away from this gray box here is that the sine and the cosecant are always really going to be closely connected to the y values. Cosine and secants are always going to be closely connected to the x values. If we're actually working on the unit circle, they are exactly the y and the x values. If we're on any other circle or on any other triangle, then we still need to consider that r may not equal to 1, and so we would need to do the opposite divided by the hypotenuse. According to what we learned back in the circle section from chapter 10 in our first chapter, the equation of this particular circle is going to be x squared plus y squared equals my radius squared, or 1. And since my cosine value is the same thing as my x value, my sine value is the same thing as my y value on the unit circle, then what we can do is we can replace that particular equation with sines and cosines. And when I do that, I'm going to get cosine squared of s plus sine squared of s is equal to 1. This is the Pythagorean identity, which I gave you a couple of sections ago. So this is something that you've seen before. All right, let's talk about some values of circular functions. A couple things to point out here is that finding exact, that word exact, this is important. This means that you're not going to be using the calculator on this. You will be using more than likely the unit circle on this, but no calculators whenever it says find the exact value. And something else that you will want to know, this phrase circular functions, this is code for work in radians. So when it talks about circular functions, just understand that that's a hidden message to work in radians. So this example number 1 says that we should find the exact value of sine of negative 3 pi. Well, the first thing you have to do is you have to know where 3 pi is, and then you can find out where negative 3 pi is. So if I go all the way, I can count my way around the circle. If I've got here's where 0 is. If I'm going this direction, here's where pi is. And then I keep on going, here's 2 pi. If I keep on counting, here's 3 pi. So if I go in the negative direction, then I've got negative pi, negative 2 pi, negative 3 pi. So that will be where the position of my negative 3 pi. So my sine, cosine, any of my trig values is going to be the exact same as what they are at pi. So my sine value there is going to be my y value, which is going to be 0. My cosine value is going to be my x value, which is negative 1. And my cotangent, remember, is going to be my x value over my y value. So that's going to be negative 1 over 0, which is going to be undefined. All right, for example number 2, again, we're looking at find the exact value. And this says to use specified methods. I'm going to be honest with you. If you use the same method on all 3 of these, I'm totally fine with that. My goal for you is simply to be more comfortable with the unit circle. So part A says to use the unit circle to find the exact values of sine of 4 pi over 3 and cosine at 4 pi over 3. So 4 pi over 3 is this guy down here. My long value is going to be my sine value. My y value is going to be my sine value. And so this is long and going down, so it's going to be negative root 3 over 2. My short value, Used an eraser there. My short value is going to be going to the left. That's going to be my x value and also my cosine value, which is going to be negative 1/2. For part B, it says to use the unit circle and the definition of tangent to find the exact value of tangent negative 9 pi over 4. Before I can use either one of these, I need to figure out where negative 9 pi over 4 is. And so if I'm counting around my circle, again, we have to go in a negative direction. If I go all the way around, this is going to be 8 pi over 4, which is the same thing as 2 pi in a negative direction. So if I go all the way around, this is negative 8 pi over 4. If I go one more pi over 4, that's going to be negative 9 pi over 4. So negative 9 pi over 4 is going to be in the same location as 7 pi over 4. So finding the tangent is going to be the same for both of those. My tangent, remember, there's a couple ways to do this. You could say it is my y value over my x value. You could say it's my sine value over my cosine value. Either way, the legs here are identical to each other. And so my y value over my x value is going to be 1, except that one of them is negative, so it's going to be negative 1. Now, letter C, use reference angles and radian to degree conversion. Again, I'm not really so concerned that you use that. I'm fine with you just using the unit circle on this. Find the exact value of sine of 11 pi over 6. 11 pi over 6 is right here. It's the last spoke before we complete our unit circle. The sine value is going to be my y value. It's going down and it's short, so this is going to be at negative 1/2. All right, next we're going to use the calculator. So pull out your calculator, and you'll notice that each of these 4 angles is a radian angle, and we know that because of the fact that there are no degree symbols. So the first thing you need to do is you need to change your calculator mode into Radian mode. Go ahead and do that before you start entering things in. So for the first example, for part A, all you need to do is just simply type in sine of 3.42, and you should get negative 0.2748. Same thing with part B, just simply type it in, and you should get 1.0790. Now, the problem with part C is that we don't have a secant button. And so what you're going to need to do is you're going to need to use your reciprocal identities. The first thing we'll do is we'll change secant into 1 over cosine of 5.6041. And then that's what we will type into the calculator as is. And when we type that into the calculator, we should get 1.2851. Same thing with part D. We don't have a cosecant button, so we'll change that into 1 over the sine of my angle. We'll type that into the calculator as is, and we'll have negative 2.5198. So make sure you tried each one of those. All right, and this is just a reminder here. Make sure that you are in Radian mode when you're looking at these. This next section here, this is a repeat of what we did in the previous section. And so when you're using the sine inverse, cosine inverse, tangent inverse, that does not show that they are reciprocals. It just simply means that they are inverses. And remember that inverses find angles. Anytime I want to find an angle, I'm going to use, anytime I want to find an angle using the calculator, I'm going to use inverses. One interesting thing to note in my radian mode is we understand our radians of the 4 axes is 0, pi over 2, pi, 3 pi over 2, and 2 pi. What we tend to forget sometimes is that that can be represented by a decimal as well. It's an approximation. And so I just put those values on the unit circle there so that you can see what those decimals are. That's going to help us in our next 2 questions. Actually, only in the next question. So for part A, it says to approximate. So again, that's your key there that you're going to be using the calculator. Approximate the value of S, which is my angle. My angle is going to be in the interval from 0 to pi over 2. So it's going to land in the first quadrant if cosine of my angle is equal to 0.3210. So the first thing I'm going to do is I'm going to rewrite this as an inverse. So S is going to equal cosine inverse of 0.3210. And then I'll use my calculator to type this in. So you're going to type in second cosine 0.3210. and you'll get 1.2440. And you'll notice you always want to check your work and make sure, hey, does that really meet the restriction? 1.24 is definitely in that 0 to pi over 2 quadrant because it's a smaller number than 1.57. In the second example here, it says to find the exact value. So this is a clue that we're not using the calculator. We're going to be using the unit circle. We're looking for an angle. Specifically, our angle is going to be in the fourth quadrant because it says it's going to be between 3 pi over 2 and 2 pi. And we're told that the tangent of that angle is equal to negative root 3 over 3. So I've given you kind of a little bit of a how-to list here. The first thing you want to do is plan which quadrants is that. This is where you're using all students take calculus. When you look at this, it says that your tangent is negative, and so you ask yourself, where is tangent negative? And you know that that's going to occur in quadrants 2 and 4. Specifically, we want to focus on quadrant 4 because that's what the restriction in the directions say we're going to focus on. So that's first. We want to plan out which quadrants we could have answers in. Number 2, you're going to use the unit circle to find your values. You're not going to be using the calculator for this. So when I look here, the first thing that I remember is that the tangent is the same thing as sine divided by cosine. So what we're looking for is an angle in the fourth quadrant, some angle S, that when I take the sine value divided by the cosine value, I'm going to get a root 3 over 3 with a negative. That can't possibly occur in the middle of the quadrant because tangent in the middle of the quadrant gives me a negative 1. So the only two places, and you can see that I've marked them on my circle here, the only two places that that can happen are going to be at 5 pi over 3 or 11 pi over 6. So what we're going to do is we're going to look at each one of those individually. If my option number 1, if I'm choosing the 5 pi over 3 position, then my tangent at 5 pi over 3, remember this is sine over cosine, is going to be negative root 3 over 2 over 1/2. Again, negative root 3 over 2 is my sine value because that's my y value over a positive 1/2. When I invert and multiply, I'm going to not get negative root 3 over 3. So I can throw out this particular option because it does not give me negative root 3 over 3. So then option number 2 is that we could use the 11 pi over 6 position. So if my angle is 11 pi over 6, then my tangent of 11 pi over 6 is going to equal, again, sine value over cosine value. So this is going to be my sine value is going to be this short leg, and my cosine value, the x value, is going to be my long leg. So that's going to be a negative 1/2 over a root 3 over 2. When I simplify this by dividing fractions, multiplying by the reciprocal, I'm going to get negative 1 over root 3, which is going to simplify to negative root 3 over 3. So then what we understand from that is that 11 pi over 6 is the option that will work. We're going to check number 3, check to see that the answer matches my restriction. It does. It's in the fourth quadrant. So I don't need to adjust accordingly because of the fact that it does meet that restriction. So my S value then for the final answer, my S is going to equal my 11 pi over 6.